Let's follow up the last podcast on strategies for dry lands with uh, this report on the global threat of drying lands, regional and global aridity trends, and future projections. I always talk about how future projections are uncertain beyond a couple of decades. They totally depend on the scenarios we assume. This report from the United Nations Convention to Combat Desertification obviously relies on those projections, but we should treat these as risks and be prepared to deal with them and not worry so much about the fact that there are uncertainties when there are resources that are limited in terms of what all you can do. You want to be careful, but the numbers we looked at before on how many people live on dry lands, how much of the food system is gaining from dry lands up to 40%, livestock contribution up to 50%, and so on. We have to worry about dry lands, but also the drying lands. So let's read the executive summary and then look at some main results. Understanding aridity and its consequences for ecosystems and societies is critical in today's changing climate. Aridity, the relative long-term lack of available life-sustaining moisture in terrestrial climates. That's the definition. You obviously need an indicator to say, when you say aridity is going up or there is a trend in aridifying of lands or drying of lands, then you need to quantify it with an index. So that's the relative long-term lack of available life-sustaining moisture in terrestrial climates, which has to translate to a metric. So this significantly affects land degradation, desertification, and the overall resilience of ecosystems and human communities. Aridity-related land degradation and water scarcity have been linked to food and water insecurity, poor soil fertility, losses in crop and plant productivity, biodiversity declines, ecosystem degradation, intense sand and dust storms, wildfires, poor health, and large-scale human migration. Human-caused climate change, meanwhile, is a main culprit for changing aridity around the world. Assessing aridity trends and future projections can help to develop resilient adaptation and mitigation strategies in the face of climate change. This report addresses the challenges in assessing aridity. As we said, we need to find metric, and provides a novel and thorough assessment of aridity's current and future trends. So we'll look at historical periods and future projections, including aridity's multifaceted and often cascading impacts using new analyses and an up-to-date literature review. So there's a part of the report that is a meta-study. I'll skip most of the details. The report underscores the importance of adopting a widely accepted climatic approach based on the Aridity Index AI, a measure of aridity that uses the ratio of precipitation to potential evaporation over the medium to long term and highlights the importance of distinguishing the long-term climatic conditions of aridity from the short-term anomalous periods of water shortage known as droughts. So the long-term lack of available life-sustaining moisture is important here because that's the aridifying trend. Droughts can come and go within the season. You can have short droughts that recover quickly, or you may have consecutive droughts in 2 years, but that's still not a trend in aridification, right? The report finds that rising aridity is threatening people and environments in almost every global region. More than 3/4 of all land on Earth experienced a drier climate during the 3 decades leading up to 2020 compared to the previous 30-year period, and global drylands expanded by about 4.3 million square kilometers, an area equal to half the size of the continent of Australia, Oceania, the surrounding islands, to cover more than 40% of the global land, excluding Antarctica. If the world fails in an effort to curb greenhouse gas emissions, another 3% of the world's humid areas are projected to transform into drylands by the end of this century, that is 2100. Meanwhile, people living in drylands have doubled in number from 2.3 billion, more than a quarter of the global population over the past 3 decades, and models suggest as many as 5 billion could inhabit drylands by 2100 in a worst case climate change scenario. Again, these are risks we have to deal with and not worry about uncertainties that come with these kind of numbers. These billions of people face even greater threats to their lives and livelihoods from climate-related increases in aridification and desertification. The report argues that sustainable adaptation measures are crucial to address the escalating challenges of climate change and aridity. Alongside ongoing mitigation efforts, these measures range from broad, large-scale initiatives that deliver multiple co-benefits to more localized approaches focused on marginalized, under-resourced, underrepresented, vulnerable, and involuntarily immobile communities. They don't have the resources to move around as aridity makes their lives and livelihoods worse. The report argues for sectoral adaptation approaches linked to sustainable agriculture and water management, as well as for education, awareness, and governance of aridity and aridity responses. Proposed actions for policymakers present a multifaceted approach advocating for enhanced monitoring, sustainable adaptation practices, evidence-based planning, and effective strategies for adapting to irreversible land degradation. The report highlights effective and sustainable adaptation practices for aridity, together with recommendations for the comprehensive monitoring and reporting frameworks, integrated sectoral plans, capacity building programs, and policy incentives linked to performance indicators. Governance frameworks for responding to aridity based on multi-scale and multi-sectoral partnerships are suggested to enhance public awareness, resilience, capacity building, and technology use for risk reduction and aridity adaptation, fostering international collaboration and alignment with existing initiatives. Okay, so here is what UNCCD does, the Convention to Combat Desertification. Basically, they provide UNCC's strategic guidance in implementing adaptive measures can inspire actionable solutions that address the multifaceted impacts of aridification on ecosystems and societies, paving the way for a future in which communities are better equipped to adapt to the changing landscape of our planet. Okay, so there are some key words. This is a glossary. You know, adaptation is, aridity is basically a climatic condition that we talked about, how it is significant deficiency in moisture, and there is a time scale involved to separate it from droughts, right? Aridification, of course, is the long-term process. Desertification is land degradation in non-desert dryland. So arid, semi-arid, and dry subhumid regions transition to deserts, and that's desertification. Obviously a slow process. We look at chronic changes and acute stressors that combine. If you have aridification trend underway and then heat waves keep coming, then they obviously desiccate the soils much faster, and the vegetation, vapor pressure deficit, etc., can begin to have serious impacts that make the situation worse and may accelerate the transitions. Drylands are defined using the aridity index and include areas classed as hyper-arid, arid, semi-arid, and dry subhumid. The AI is calculated by dividing mean precipitation by potential evapotranspiration. As we mentioned, we must emphasize it again. Drylands have an AI of 0.65 or lower, meaning that potential evapotranspiration is at least 45% greater than actual mean precipitation, so you are constantly losing water. Okay, so there are enabling conditions, land degradations, and of course the impacts. Resilience here is the ability of social or ecological system to absorb disturbances while retaining the same basic structure and ways of functioning. So there is a perturbation or a shock, and then you get back to functionality. As we saw in the previous podcasts, this depends on risk and the resilience. And as we said, low risk, low resilience may work better in some cases than high risk, high resilience systems. you may not recover in a high risk situation. So this includes the capacity of self-organization and the capacity to adapt to stress and change. Risk is, of course, the potential for adverse consequences for human or ecological systems, recognizing the diversity of values and objectives associated with such systems. And in other contexts, risk has a more specific definition, but here we will stick with this. Vulnerability is critical if you want to strategize to deal with these, because you want to know the risk and then know the vulnerability and reduce vulnerabilities. So these are conditions determined by physical, social, economic and environmental factors or processes that increase the susceptibility of an individual, a community, assets or systems to the impacts of hazards such as drought. So vegetation may be vulnerable, people may be vulnerable, water systems may be vulnerable, agriculture may be vulnerable, and so on. So vulnerability is an inherent property of a system that exists independently of the external hazard. The hazard just comes and tests your vulnerability limits. This is the same level of hazard that can impose different consequences for different individuals, communities, countries, regions and other systems due to distinct underlying vulnerabilities of these systems. In turn, vulnerability to a hazard and its impacts can be altered by the actions of society, such as land and water management practices, among others, which means it's not just hazard, vulnerability, exposure, but the response can affect vulnerability. Obviously, that's what you want to do. You want to set up actions that reduce vulnerabilities as quantified already, right? So key messages, let's read these so that it makes it easier to look at the rest of the figures, so that we have the key messages in mind. More than 3/4 of all land on Earth experienced a drier climate during the 3 decades leading up to 2020 compared to the previous 30-year period. We said this in the executive summary. Global drylands, areas in which precipitation is less than 65% of the atmospheric evaporative demand, expanded by about 4.3 million square kilometers, as we said. Drylands now cover almost 41% of the global lands, excluding Antarctica, as we said. Much of Aridity's recent rise can be attributed to human-caused climate change, the warming especially. If the world fails in efforts to curb greenhouse gas emissions into the future, another 3% will become a dry land by the end of this century. People living has grown 2.3 billion in 2020, up from 1.2 billion 30 years earlier. That is, those living in drylands comprised almost a third of all the people on Earth, compared to just over a fifth in 1990. So more people are moving into drylands, or drylands are expanding to include more people. Right? So about half of the world's dryland inhabitants are found in Asia and Africa, which are highly vulnerable to climate change, and they are not big contributors to climate change thus far in terms of accumulated carbon. The most densely populated drylands are in California, Egypt, eastern and northern Pakistan, large parts of India and northeastern China. Obviously, California is much less vulnerable because of all its wealth. Climate models suggest as many as 5 billion people could inhabit drylands by 2100 in a worst-case climate change scenario. Dryland inhabitants in this scenario would more than double the current number, and would mean 2 in every 5 people on the planet live in drylands by 2100. Hotspots showing significant dryland expansion include Western United States, the Yucatan Peninsula, I don't know how they say it, Yucatan maybe, northeastern Brazil, northwestern Argentina, the entire Mediterranean region, the northern side of the Black Sea, the Sahel, the Rift Valley, northeastern South Africa, the bordering area between Russia and Kazakhstan, large parts of Mongolia, and northeastern China and southeastern Australia. Okay, so that's a lot of land across the planet. Human-made greenhouse gas emissions have played a key role in the expansion of drylands, especially over the past 3 decades, according to climate simulations that show a pronounced global drying trend beginning in the 1950s and accelerating from the 1990s. So we have data and models confirm in attribution exercises that greenhouse gas emissions contribute to this. We talked about detection and attribution elsewhere that you can look up on my channel. Impacts of increasing aridification coupled with anthropogenic processes lead to land degradation and desertification and water scarcity. These in turn can trigger cascading effects among many associated negative environmental and socio-economic consequences, including food and water insecurity, poor soil fertility, losses in crop and plant productivity, biodiversity declines, ecosystem degradation, intense sand and dust storms, wildfires, poor health, and large-scale human migration, which means people who migrate are going to face a lot of issues where they end up. Nobody likes migrants, right? More than a fifth of all land could experience abrupt ecosystem transformations in response to rising aridity by the end of the century, according to recent projections. Okay, so there are some uncertainties in there, but you still have to worry about these. Few more points. Increasing aridity is expected to play a role in larger and more intense wildfires in the climate-altered future, not least because of its impacts on tree deaths in semi-arid forests and consequent growing availability of dry biomass for burning. Europe is likely to be especially affected by this. Mediterranean and the Middle East, Western Asia are warming very rapidly. It's obviously bad news in terms of vapor pressure deficit and wildfires and drying in general, but they have also affected winds over the Arabian Sea and rainfall extremes over Pakistan and northwest India and so on, and Pakistan is a very vulnerable country. More than 2/3 of all land on the planet excluding Greenland and Antarctica is projected to store less water on land by the end of the century if greenhouse gas emissions continue to rise even modestly. Aridity is considered the world's largest single driver behind the degradation of agricultural systems, affecting 40% of Earth's arable lands. That's bad news. Rising aridity has been blamed for a 12% decline in gross domestic product recorded for the African countries between 1990 and 2015. Okay, 12% decline in a poor country can be a massive hit. Rising aridity's impacts on poverty, water scarcity, land degradation, and insufficient food production have been linked to increasing rates of sickness and death, especially among children and women around the world. Rising aridity and drought play a key role in increasing human migration around the world, particularly in the hyper-arid and arid areas of southern Europe, the Middle East, and North Africa and southern Asia. Few more. This one is we have 2 more pages, but let's just read them since the rest you can then skip the rest of the report or podcast if you want. Quantifying future socioeconomic impacts can enhance equitable societal resilience. While some successful local and regional adaptation measures exist, transformational approaches are needed that blend traditional and local knowledge with evolving up-to-date scientific understanding. Stakeholder engagement is crucial to enhance resilience to aridity, requiring sufficient financial resources, governance structures, partnerships, capacity building initiatives, evaluation and learning, along with robust monitoring mechanisms. Aridity-driven desertification, the degradation of land and terrestrial ecosystems in non-desert dry lands, can result in a cascade of potentially devastating environmental and socioeconomic consequences. While many aridification impacts in the world's drylands are expected to intensify and expand into new areas in the climate-altered future, a better quantification of future socioeconomic impacts is needed to plan and implement adaptation measures that increase the resilience of vulnerable people. Many poor rural dryland populations have historically implemented sustainable practices to adapt their agriculture and pastoral activities to aridity, but intensifying aridification and the expansion of global drylands in the future will require transformational approaches that combine traditional knowledge with evolving scientific understanding and technical solutions. So when people get used to variable climate and adaptation at some time scale, there is always a dependence on the rate of change or rate of aridification. Sometimes it's seasonal aridity because rain goes away. There may be 3 months of rain with 9 months of dryness, and they are used to managing things. But the rate at which this happens is changing in the warmer climate. That makes adaptations very difficult. So the experiential traditional knowledge may begin to fall short. Okay, stakeholder engagement supported by sufficient financial resources, governance structures and partnerships, capacity building initiatives and robust monitoring and reporting mechanisms is needed. This is all for stakeholder engagement to promote an enabling environment to significantly enhance the resilience of societies to climate aridification. Access to aridity information is essential for governments and institutions to address aridity's impacts and to develop better adaptation tools. Information generated for this report has been included in an aridity visual information tool available at this website. The tool features the global spatial distribution of the average aridity index, the aridity indicator used in this report based on the ratio of precipitation to potential evapotranspiration again over the medium to long term, and various aridity classes across the time periods of 1961 to 1990 and 1991 to 2020. We'll look at this. So this latter period is much drier now compared to the former 30-year period. The tool also includes aridity projections for 2100 based on two different emissions scenarios. Those are SSP 1-2.6 and SSP 5-8.5. 2.6, if you don't know what these are, you can look up podcasts on my channel. Shared Socioeconomic Pathway 1-2.6 is 2.6 watts per meter squared is the additional energy we'll be trapping by 2100, and SSP 8.5 is the worst case scenario or business as usual, and 2.6 is something that I think promises to keep us below 2 degrees C, if I'm not mistaken, but you can look up. So these highlight uncertainties in these projections in terms of the tool providing information. It provides monitoring feature that updates the aridity index annually using data from the past 5 years. So you have a running average of the last 5 years to look at what is the latest aridity index. The tool helps assess long-term changes in aridity by filtering out high-frequency climate variability, which is more closely related to drought events. All data within the system can be downloaded in various graded formats or as time series. Amazing, right? The aridity visual information tool is also linked to the UNCCD knowledge sharing systems search tool, which is given here in terms of the link to the website, and this provides highly relevant information for assessing aridity at local to global scales and for developing socioeconomic and environmental aridity mitigation and adaptation efforts. Okay, so we'll come back and look at further details. This podcast must already be 20 some minutes. It's 24 minutes, so that's okay. We'll have at least one more podcast, I'm sure, but this is an important topic and there are some really interesting and important messages that we will look at in the next podcast then. Okay, see you in a bit.